Now we are in the FFT module of the impaq Elite Dynamic Signal Analyzer. So before we conduct a bump test, we will go to the setup and select FRF, coherence, and then deselect the enveloping because you are not going to use enveloping in this measurement. Enveloping would be used for bearings. In the next menu, we'll select the bandwidth lines, 2 kilohertz, and then the lines of resolution. In this case it's set to 3200, and we will adjust the linear windows. So we'll keep it as linear, and then we'll adjust the number of averages to 3, and be sure to set the overlap to 0%. Preview will set to manual, and then overload rejection will be set to on. So this whole average window is designed for when you strike your structure to be correct. Next we'll look at triggering. So we'll set the channel 1 as the trigger, that's the hammer. Level is 20 millivolts. Positive slope. And in this case we'll change the delay percentage from a -1% to a -5%. Next we'll go to the channel setup. If you look, we have channel 1, 2, and 3 and 4. We'll turn them all on. Channel 1 will be the hammer. Channel 2, 3, and 4 will be the triaxial accelerometer. So the input range is correct. They're all IEPE. However, the windowing for the accelerometer will change to rectangular, and that'll be for channel 2, 3, and 4. And then in channel 1 we'll set that to force because we are using a force window. The next thing that we'll look at is the channel ID. So for channel 1 we'll label this as 99. And then channel 2, 3, and 4 we will change the axes. So channel 2 will be plus X, channel 3 will be plus Y, and then channel 4 will be plus Z. So that way we have a representation of exactly what the accelerometer is. The other column that we'll be looking at is the auto advance. In channel 1 we'll have off, but channel 2, 3, and 4 will have on, and this has to deal with the auto saving. So as you move your accelerometer to the next point, it will be ready to auto advance the file name. The next thing we'll do is look at the engineering units. So we will decide or define what this is. So the sensor type for channel 1 is force, and we will put the sensitivity in this, and in this case it's 11.4 millivolts per newton, and in the display we'll have newtons as well. For channel 2, 3, and 4 it's acceleration or accelerometer, and we'll leave the sensitivity at 100 millivolt per G, but on the display unit we also will have it in G's, meaning that we will see newtons and G's in the display window. The next thing that we will do is adjust the display windows. In the display windows we will have 4 different windows. In the first window we will set to frequency response function, or FRF. We will set the units to dB and then display the channels of 2, 3, and 4. Next we'll look at the second window, and we will show the coherence with the linear scale, again displaying channels 2, 3, and 4. So the two windows, one on the upper left is FRF, the one below it is coherence, and in the third window we would like to show the time waveform of all the channels and then in the fourth window it is recommended to show the auto spectrum in dB for channel 1. Once our display windows are set up, we need to talk about the file naming options. We can have a format that shows the label IDs for each one. We can autosave. We can have a thing called auto prompt data saving, meaning that it will remind you, is this what you want? So after our setup is complete, we can select to save this data setup, which we will do, and we'll call this bump. So the next time that you want to run this particular test, all you have to do is go File, Open Setup, at Bump, and it will retain all that information that we had before as far as the display windows, as far as the setup and everything, and you're ready to go. So now we're ready to begin a test. To begin, what we do is we push the start button. And as you can see, it's waiting for trigger, and we strike the T-plate. And if you look, it's a good strike. It's a good hit. Press accept. Now, waiting for trigger, strike it again. We're on our second test. Either accept or reject. And if you make a bad hit, like say a double hit, you can observe the time waveform and see the bad signal, in which we can reject it and take another one. We have the ability to save this to the file name, but first I want to check the quality of the measurement. I'm using a plastic tip, and if you check in the power spectrum in channel 1, it decays by almost 24 decibels. So you can see that it is not a good hit. So we can replace this with a metal tip and then redo this test again. So now we redo the test, push start, and we will strike our structure, accept that, again, second time, and then finally a third time. It's reading the buffer, and the results will be displayed. And it says save data to a file, and we're ready to go. So now you can look at the difference in the dB by changing the tip. We have now like almost 3 dB, less than 3 dB amplitude change, which is much better than the first one. So now we can go ahead and go File, save the data as the point ID, and then we can go on to another measurement where we can move the triaxial sensor to the second point, start the test again, smash the structure, and repeat the test, and then do 3 more measurements again, and then repeat it again. So using the impaq Elite for doing these bump tests or modal analysis is really quite good. It has a tool that you can create a unique file name for each test so that it's easy to find the next time, and the setups are very straightforward. So thank you very much for taking the time to look at a bump test, and if you have any questions, please let us know.